conducting a hypothesis testing, and understanding significant levels. In this quick guide, we will explore the process of conducting hypothesis testing at certain significant levels, providing learners with a comprehensive understanding of the topic. What is hypothesis testing? Hypothesis testing is a statistical method used to determine whether there is enough evidence in a sample of data to support a particular hypothesis about a population parameter. This method involves two competing hypotheses. Null hypothesis, H0. This is a statement that there is no effect or no difference, and it is a hypothesis that researchers aim to test against. Alternative hypothesis, H1 or HA. This is a statement that indicates the presence of an effect or a difference. Understanding significance levels. The significance level, denoted as alpha, is a critical threshold that researchers set before conducting a hypothesis test. It represents a probability of rejecting the null hypothesis when it is, in fact, true type 1 error. Common significance levels include 0.05. This means there is a 5% risk of concluding that a difference exists when there is no actual difference. 0.01. This level indicates a stricter criterion for rejecting the null hypothesis, with only a 1% risk of a type 1 error. 0.10. This level is less strict and allows for a 10% risk of making a type 1 error. Selecting the appropriate significance level is crucial, as it impacts the outcome of the hypothesis test. Steps for conducting hypothesis testing. 1. State the hypotheses. Begin by clearly stating the null and alternative hypotheses. For example, H0. The average height of male students in a university is 175 centimeters. H1. The average height of male students in a university is not 175 centimeters. 2. Choose a significance level. Decide on the significance level alpha for your test. For this example, let's use alpha equals 0.05. 3. Collect data. Gather sample data relevant to your hypotheses. For instance, you might measure the heights of 30 male students. 4. Calculate the test statistics. Depending on the type of data and the sample size, you will use different statistical tests, e.g., t-test, z-test. For our example, if we have a sample mean x and standard deviation, s, we can calculate the t-statistic as follows, where mu equals population mean is 175 centimeters, and equals sample size 30. 5. Determine the critical value. Using statistical tables or software, find a critical t-value corresponding to your significance level and degrees of freedom. 6. Make a decision. Compare the calculated test statistic to the critical value. If the test statistic exceeds the critical value, reject the null hypothesis. If the test statistic is less than the critical value, do not reject the null hypothesis. 7. Conclusion. Summarize the findings. For example, if you reject the null hypothesis, you might conclude that there is a significant difference in the average height of male students from 175 centimeters. Sample question. A researcher wants to test if the average weight of apples from a new orchard is different from 150 grams. A sample of 25 apples has a mean weight of 145 grams with a standard deviation of 10 grams. Conduct a hypothesis test at a 0.05 significance level. Here is the solution. Conclusion. There is significant evidence at the 0.05 level to suggest that the average weight of apples from a new orchard is different from 150 grams. Additional resources. For further reading and a deeper understanding of hypothesis testing, consider exploring the following scholarly sources. Statistical hypothesis testing. Introduction to hypothesis testing. Understanding statistical significance. In conclusion, by following the steps outlined in this study, you can effectively test hypotheses and draw meaningful conclusions from your data. Remember to choose an appropriate significance level and carefully interpret your results to enhance your statistical analyses.